Hello everyone. Now I'm going to tell about short circuit test on three-phase alternator. The main objective of this test is used to predetermine the voltage regulation of the three-phase alternator using EMF method. This method is also known as synchronous impedance method. Let us start the experiment by drag this experiment and put it in the workspace. Now you can see the circuit of the short circuit test. Below this circuit, you can see the ratings like DC shunt motor ratings and then the alternator ratings. The speed of the DC shunt motor is 1500 to 2000 rpm and the alternator speed is 1500 rpm. It has a pole, 4 poles. From this, we can say that it is a non-salient pole type of alternator because non-salient pole has less number of poles and then the high speed. The windings are delta connected and its armature current is 4.2 amps. Let me explain the circuit. Here you can see the DC shunt motor. This DC shunt motor acts as a prime mover. The output of this DC shunt motor is given as the input to the alternator because alternator is mechanically coupled to the DC shunt motor. The DC shunt motor is excited using this DC source, double pole single throw switch, and you can see the rheostat. This rheostat acts as a potential divider. It is used to increase or decrease the stator voltage of the DC shunt motor. And then we know that the alternator is a three-phase alternator. Here you can see the three phases R1, R, Y and then B. These three phases are short circuited. This short circuit current is measured using the ammeter. The ammeter we are using here is moving iron type of ammeter, and this X and Y are the field. The alternator field is excited using the DC supply, and here also you can see the rheostat. By varying this rheostat, we can adjust the current. And before start this experiment, make sure that DPST switch are kept open and the rheostats are kept at the high positions. And here you can see the tachometer. This tachometer is used to measure the speed of the alternator. Let us start the experiment. Close the DPST switch. Adjust the rheostat till you get the 1500 rpm. You can see that when the voltage increases, speed also increases. We know that voltage and speed are directly proportional to each other. We are till getting the 1500 rpm. We are going to vary this rheostat gradually. 1320, 400, and then 1500 rpm. Okay. Now we are going to excite the field by closing this DPST switch, and we are going to vary the rheostat till we get the rated armature current. We know that the rated armature current is 4.2 amps. I'm going to vary this rheostat. The rated armature current is 4.2 amps. Still getting that 4.2 amps. We are going to vary this one. We get the 4.2 amps. Now we are going to store these data by clicking this. Here you can see the start storing data option, and then click the store data. We can get the value. For short circuit test, we used to store only one reading. Here you can see the armature current, armature voltage of the DC shunt motor, and then the field voltage of the alternator, and then field current and the short circuit current of the alternator, and the speed also the motor output. Okay. Before switch off the supply, make sure that you reduce the rheostat position, you reduce the voltage, and then switch off the supply. These are all the things I would like to discuss in this video. Thank you.